The video topic is all key emerging technologies shaping future education systems, universities, TAFEs, and colleges. This video provides a comprehensive synthesis identifying all key technologies shaping future education systems, universities, TAFEs, and colleges. The list is grouped by domain, and these technologies go far beyond computing or IT technologies. Artificial intelligence and AI agents. AI and its agentic forms are the foundation of future education systems. Key impacts: personalized learning. Adaptive AI tutors and intelligent feedback systems create tailored learning pathways for each student. AI agents for academic planning and governance. Multi-agent systems optimize enrollments, staff workloads, and curriculum design. Assessment and evaluation. AI-driven analytics measure learning outcomes in real time. Administration. AI automates admissions, finance, compliance, and timetabling. Research support. AI copilots assist in literature reviews, simulation, and grant writing. Quantum technologies. Quantum computing and quantum communication will reshape research, simulation, and security in universities. Key impacts: quantum simulation enables complex scientific experiments, materials discovery, and climate modeling within the classroom or lab. Quantum cryptography protects university data and research against post-quantum cybersecurity threats. Quantum AI integration merges quantum algorithms with machine learning for next-generation educational tools. Quantum education ecosystems, new curricula and degrees in quantum information science, engineering, and applications. Extended reality, XR, technologies, AR, VR, and Mr. Immersive learning will redefine how knowledge is delivered and experienced. Key impacts: virtual laboratories. Students can perform chemistry, physics, or engineering experiments safely in digital environments. Mixed reality classrooms blend real and virtual spaces for interactive simulations and collaboration. Cultural and field experiences. Archaeology, geography, and design students explore virtual field sites or heritage locations. Robotics and human-robot collaboration. Robotics and mechatronics are transforming learning, assistance, and campus management. Key impacts: teaching and learning. Robots assist teachers, demonstrate engineering concepts, or support special needs students. Service robots manage logistics, cleaning, and safety on smart campuses. Rehabilitation and biomechatronic systems used in health and sports science education. AI-controlled exoskeletons for biomedical and biomechanical training and research. Internet of Things, IoT, and cyber-physical systems, CPS, smart, connected infrastructure forms the digital nervous system of future campuses. Key impacts: smart classrooms, automated lighting, energy, and environment control. Wearable learning devices track engagement, focus, and wellness. Research data collection, real-time sensors for environmental and engineering studies. Smart campus operations, integrated building, transport, and safety systems. Cloud, edge, and distributed computing. These technologies provide computational power and access for global learners. Key impacts: edge learning platforms, low-latency AI inference near learners. Cloud laboratories, remote access to high-performance computing and experiments. Data lakes for universities, centralized research and academic data for AI and analytics. Blockchain and Web3 technologies. They enable trust, transparency, and mobility in academic and research records. Key impacts: blockchain credentials, secure, verifiable degrees and certificates. Smart contracts for collaboration, automate research agreements and IP management. Decentralized learning systems, students own and share their educational data globally. Biotechnology, neurotechnology, and brain-computer interfaces, BCIs. These frontier fields will reshape human learning capacity itself. Key impacts: cognitive enhancement, neuroadaptive systems that detect fatigue and optimize learning pace. Brain-computer interfaces enable new ways of interaction and accessibility for all learners. Health and biomedical curricula, integration of biotech and AI in life sciences education. Advanced materials and sustainable energy technologies. The university campus will become a living sustainability laboratory. Key impacts: green buildings, materials with self-healing, energy harvesting, or carbon-absorbing capabilities. Renewable energy systems, solar, hydrogen, and energy storage technologies embedded in teaching and operations. Sustainability education, real-time environmental data integrated into curricula. Data science, analytics, and digital twins. Digital twins of campuses, laboratories, or even entire universities will support strategic decision-making and experimentation. Key impacts: student digital twins predict dropout risks, performance trends, and well-being needs. Campus digital twins optimize energy, maintenance, and traffic flow. Institutional analytics drive data-driven strategic planning. DDITIVE manufacturing, 3D, 4D printing, and advanced manufacturing transforming engineering and design education. Key impacts: prototyping labs, hands-on innovation and design thinking. 4D printing, smart materials that change shape or function over time. Curricular integration, teaching sustainability and creativity through fabrication. Cybersecurity and post-quantum security systems protecting intellectual property, digital campuses, and research networks. Key impacts: quantum-resistant cryptography, safeguards academic databases. Cyber-resilient campuses, autonomous defense systems using AI. AI-augmented programming. These democratize innovation across disciplines. Key impacts: educators and students as developers build custom tools, dashboards, or micro-apps without coding expertise. Accelerated research tools automate data processing and experimentation. Cross-disciplinary collaboration, business, science, and engineering departments co-develop digital solutions. Generative AI and creative technologies transforming content creation, assessment, and communication. Key impacts: automatic learning material generation. AI creates tutorials, quizzes, or simulations. Creative county design. AI assists in architecture, media, and design disciplines. AI-enhanced research writing accelerates publication and collaboration. Socio-technical and ethical AI systems. Universities must integrate responsible innovation. Key impacts: AI ethics education, new curricula in responsible AI and technology governance. AI governance systems ensure fairness, transparency, and inclusiveness. Human-centered design keep technology aligned with educational values. The integrative vision. All these technologies together form the technological ecosystem of the smart university. They create adaptive, intelligent, and sustainable learning environments, blending human wisdom with digital intelligence to enhance learning quality, expand access, reduce administrative burden, and accelerate research, innovation, and societal contribution. If you enjoyed this discussion, don't forget to subscribe, like, and share. Stay tuned for more insights on AI, quantum computing, and emerging technologies shaping the future of software and humanity.